For a second problem, we have these given characteristics. We have the center is now at 2 comma negative 2, so over 2 and then down 2, and that's the center. The A vertex, I guess, is at 7, negative 2. 2, 4, 6, 7, and then on the same line there, and that's a vertex. And they give us one focus point at 4, negative 2. Okay. So they've kind of given us from the center over to the right of this ellipse, and then, everything would be mirrored over here to the left as well. So, we could draw the rest of those pieces on just based on what we have. The other focus would be over here, and the other vertex would be the same distance out there too. All right, and so then the entire ellipse would go something like this. Okay, so a couple things we can tell. We already do know the center. So we do know the center, which will be going in the numerator of the equation. We also know that this is a horizontally oriented ellipse because of the location of the foci. And then we also know from the center out to the vertex is 1, 2, 3, 4, 5, and that value is A. So A is 5. And from the center to the focus point, that's 2, so that's C. So C is 2. And then again, let's draw our triangle. Here's how that triangle looks. Okay, do notice that the triangle just goes to the focus in the center. It does not extend to the major axis vertex, okay? So just be careful with that. All right, here is our triangle. So again, let's see, the distance to the focus is 2. The major axis, A is 5, and our unknown again is B. So we'll do B squared is equal to, nope, just kidding. B squared plus 2 squared is equal to 5 squared. So B squared is equal to 25 minus 4, or 21. And then if you want to know B, you take the square root of 21, and that's that value. All right, so if it's a horizontal ellipse, we know we're going to do our x minus h squared, and then a squared, the larger number, is going to go under x, and then y minus k squared over b squared, and they're always equal to 1 if they are an ellipse. Okay, so we have all the pieces now, so we'll do x and then minus 2 for the center over our a is 5, so our a squared is 25. And then our y minus a negative 2 makes plus 2 squared over our b squared, which is down here, 21, and that is equal to 1. And that is the second equation of an ellipse on this page. And then just to continue on down the page, there's just a little bit more information here to finish this out. I think we can do that in this video. So we already saw the general form of the equation of a circle, and we are going to look at the general form of the equation of a parabola and a circle. We already did circle, ellipse, and then eventually hyperbola as well. So the general form is our ax squared plus by squared plus cx plus dy plus e equals 0. So remember that this form is really not for graphing, okay? The form up here, this is called standard form, right, where it has the information we would need for a graph. And then this is just called general form, actually, because the equation is basically the same for all the conic sections, and then there's just little tweaks for each one. So for example, for the ellipse, the thing that makes it different than a circle is that A and B are different numbers, but they do have to be the same sign. Usually they'll both be positive, but technically they could both be negative and it would still be an ellipse. And then we are going to look at when one is positive and one is negative next time. So that is what makes an ellipse. How is this different then, this question, the ellipse versus the circle? Okay, so the equation was quite similar, okay, but just to review, this equation of the circle was more like this. Y squared, or sorry, x squared plus y squared plus ax plus by plus c is equal to 0. Now the letters, it doesn't matter that this one was a and now this one is a. The idea is just these letters just represent a coefficient, a number in the equation. And notice for the circle, the number in front of the x squared and the y squared term is going to be 1. Okay, so when we compare the two equations, we have to have, for an ellipse, a and b would be different. And that is why it ends up with two foci. See, because it like stretches it out in one direction more than in the other direction. Versus a circle is kind of like an ellipse, except it's stretched the same in the x direction as it is in the y direction, just creating, you know, the foci basically just are on top of each other, right? And so this it's stretched in the same direction, in the same amount. So basically, in a circle, the coefficients of x squared and y squared are the same. You can always divide them then until they are equal to 1. But technically, you know, they could be the same number, any number, and then you would simplify so that they were 1. All right.